Today we're going to do an experiment looking at a particular type of microbe, one of those tiny little living things I talked about in our bread hand washing experiment. We are going to look at a microbe called yeast. It's a type of fungus, which is one of the three main types of microbes. Now yeast, there's lots of different types of yeast. Some yeasts can infect us and make us poorly, they're a type of germ. Other yeasts just live outside in the mud, in the soil, on plants. But some yeasts are useful to us and we use them in the kitchen. You can get brewer's yeast, which is used for making beer or wine. And you can get baker's yeast, which is used for making bread. And that's the type of yeast we're going to look at today. Now, this yeast is a living thing. So it needs certain things to stay alive, just like any kind of animal. It needs food, it needs water, and it needs warmth or shelter. It needs to be at the right temperature. So we're going to do an experiment today to find out what the best type of food for yeast is and what the best temperature for yeast is. It's one that you can do at home if you want to, or you can carry on watching to find out what happens when I do the experiment. So if you want to do the experiment at home, you will need some baker's yeast, some small pots or glasses or cups. Flour is useful, but you don't need it if you haven't got it. You'll need some sugar. I'm using sugar cubes, but you could just use spoons of sugar. Spoons, stirrers, and some warm water. Depending on which experiment you do, you'll then also need either some salt or some cold water and some hot water. You might also want a timer so you can keep track of how long the experiment takes. So, as I mentioned with the equipment, there's two different experiments that you can do. You could do both of them, or you could just do one, but they're two separate experiments that we can't mix up. That's because we want to make our experiments a fair test. That means that for each experiment, we only change one thing. So for one experiment, we can change what kind of food we give our yeast, and we can either give our yeast sugar or salt or nothing. We'll give it no food. So that's one experiment. We can give it different types of food. But if we do that, everything else needs to be the same. So it needs to have the same temperature of water, the same amount of flour, and the same amount of yeast. The second experiment that I'll show you is to look at what temperature of water is best for the yeast. So for that, I could give the yeast either cold water, or warm water, or hot water. But everything else needs to be the same. So for this experiment, I'll give all of the yeast the same kind of food, and they'll still have the same amount of flour and the same amount of yeast. That's how we make sure it's a fair test. By only changing one thing, we know any differences we see are because of that one thing. So it'll either be changing the food or changing the water temperature. So I'm going to start with which is the best food for yeast experiment. So first I'm going to put in all the things that are the same, starting with about 5 spoonfuls of flour. I'm using quite small glasses, so I'm going to do small spoonfuls of flour. I'm making sure each spoonful is about the same size. There's 5. I'm going to put 5 in each cup, so they're all the same. So it is a fair test. 3, 4, 5. And our last one. 1, 2, 3, 4, 5. Now, the point of the flour is that it helps to catch the bubbles from the yeast. And it sort of gives the yeast somewhere to live. It's kind of the home for the yeast. Now, when yeast is happy, it makes lots of bubbles. So in our experiment, we're going to be looking for those bubbles that get caught by the flour, because they will show us which yeast is the happiest and which yeast is growing the most. So we've had our 5 spoonfuls of flour. Next up is 1 spoonful of yeast into each one. And then 1 spoonful of food in each one. So my first one gets a spoonful of sugar. My sugar pot, I've labelled it up so I don't get confused. My second one is salt, so that gets a spoonful of salt. And my third one is nothing, so that one gets a spoonful of nothing. Lastly, I'm going to add some warm water to each one. I'm going to fill each pot about half full with warm water. Now my glasses have got little measuring marks on them, so I can make sure they're all exactly the same height. Lovely. But if you're just using cups or glasses at home, you can just fill them up to roughly the same height. Then, with all that flour in there, they all need a good stir to get the yeast and the flour mixed in and to let the salt and the sugar dissolve. Now, it'll take a few minutes for anything to happen with these. So, before they get started, you've just got time to make a prediction. What do you think will happen to each one? Which one do you think will be the happiest yeast? And which one will bubble the most? You could write your prediction to describe what you think is going to happen, or you could draw it. You could draw each pot from the side and show if you think it's going to bubble or not. Show what you think will happen to each yeast. So that is our which food is the best experiment. We'll leave that one going. I'm going to start a timer so we can see how long it's been going for while I set up the second experiment we're doing, which is which temperature is the best. So this experiment starts very similar. Just like before, we need to put 5 spoonfuls of flour into each pot so that the yeast has somewhere to grow, somewhere to live, and it makes it easier to see any bubbles made by the happy yeast. So I'm trying to make all my spoonfuls about the same size because I'm using very small cups. I can use quite small spoonfuls. 5, so that's 5 in each. I still want 1 spoonful of yeast in each cup. And this time, I'm not changing the food, I'm changing the temperature. So each one is going to get 1 spoonful of sugar. That's its food. Now comes the different bit. In my cold cup, I'm going to put some cold water that I've had in the fridge. In my warm cup, I'm going to put some warm water that feels nice to my hand. It's a bit colder than the bath, but it's some nice warm water. And in the hot one, I'm going to put in some hot water, fresh from the hot water tap. Doesn't need to be boiling, not from the kettle, but it's from the hot water tap and it's a bit too hot to put my hand in. I don't really want to put my fingers in there. And then just like before, you need to give all 3 a good stir to mix up the flour, mix up the yeast, and to make sure the sugar dissolves. And just like before, it will take a few minutes for them to get started. So you can make a prediction, which is saying what you think will happen. Which temperature of water is going to bubble the most? And which one's going to bubble the least? Which one do you think our yeast will be happiest in? Cold water from the fridge, warm, nice water, or hot, hot water? Make your predictions. I'm going to pause the video now and we'll come back in 5 minutes to see what has happened. We're back again. I ended up leaving it for 10 minutes because not much was happening after 5, but we can see a few differences now already. There are a few bubbles on sugar. I can't see any bubbles on salt, and we have a few bubbles on nothing as well. That's what for our which food is best experiment. We'll leave them a bit longer to see if anything else happens. On which temperature is best. Maybe some bubbles on cold, I'm not sure. There's definitely a few bubbles on warm. And it looks like there might be a few bubbles on hot as well. So we're going to leave this running for another 10 minutes or so. And then again, we'll come back and see if anything else has changed. This is one of those experiments where you need to keep checking back every 5 or 10 minutes to see how it changes, over time. See you in a bit. So now we're at 20 minutes and I've moved the camera so we can have a look at our experiments from the side. So we'll start with the different temperatures of water. And they've all got sugar and they've all got flour, so only the temperature we've changed. Our cold water hasn't done a lot. The flour's all sunk to the bottom. There's a few tiny bubbles in the top, but not very much has happened. When we move to the warm water, that is quite different. You can see there's the flour and the water at the bottom, and then this whole layer is all bubbles. So there's lots of these floury bubbles at the top. We look at the top. You can see it's kind of domed up with those bubbles. Then if we go to the hot water, there's not really anything there. It's all the flour and the water still kind of mixed together. If we look at the top, there's no bubbles there at all, just some little lumps of flour or yeast. I'm not sure what they are. So that's what's happened with our cold, warm and hot water. Let's have a look at the different foods next. We'll move these out of the way. So our sugar. So these are all with warm water, remember, and flour. The sugar one has bubbled up quite nicely. You can see the water flour layer at the bottom, and then all these bubbles at the top. It's kind of domed up as well. The salt, oh, there's maybe 1 or 2 bubbles there, but very, very little. It's looking very flat compared to the sugar. Our one with nothing, oh, it has done something. So you can see there's a little layer of bubbles at the top there, but not nearly as much as the sugar, the one that had sugar to eat. So, why have we got these results? So, were those results what you expected? Is it what you predicted? If you predicted something different, that's absolutely fine. It means that you've now learned something by doing this experiment, which is great news. But why did we get those results? Let's look at the different foods first. So we had our sugar one bubbled up lots and lots. In fact, if I turn it round, you might be able to see there's like little volcanoes of bubbles coming up from the flour at the bottom. So the yeast is really happy in here. It really likes eating sugar. Sugar has got loads of energy in it. That's a lot of the reason why us humans like eating it as well. It's got lots and lots of energy, but it can easily be too much energy. It's because we don't need to go out hunting for our food anymore, or gathering or running away from predators. So food that's very rich in sugars like this can easily give us too much energy, and that can be unhealthy. But for the yeast, it's perfect. Now for the yeast we fed salt to, it's a very different story. This is the sugar, this is the salt. It hasn't bubbled at all. You can see the flour yeasty mixture is all sank to the bottom. We've just got the water at the top with hardly any bubbles. Too much salt is actually poisonous. A little bit of salt is very important for most animals, definitely for us. We need a tiny bit of salt in our diet, but too much salt, like a whole spoonful for this poor yeast, or if we ate cups of salt, that would be too much for us. It's actually poisonous. It harms our bodies and it harms our cells. So sadly, the salt that I tried to feed to this yeast has actually killed the yeast. So it's not happy at all, it's not bubbling, and it's not growing. The one that we didn't feed anything to has bubbled a little bit. You see a little layer of bubbles there, but not nearly as much as the one we fed sugar to. So even without adding extra sugar, there's a little bit in there to let the yeast grow and eat. It's probably eating some bits of the flour. There might even be some bits of sugar mixed in with the yeast. So there's a little bit of food in there, so it's able to grow and bubble a bit. It's a little bit happy, but it's not nearly as happy. It hasn't got nearly as much energy or food as the one that we fed sugar to. So that's what's going on with the 3 different foods we tried. Now, how about the 3 different temperatures? The cold water has bubbled a tiny bit, but not very much at all. Cold slows everything down. When an organism, when an animal or a living thing is cold, it does everything slowly. So it's going to be eating the sugar in there really slowly, bubbling really slowly. So we haven't seen anything happen yet. Animals like us, we are very clever because we can keep ourselves warm by eating food. So even when it's cold outside, we can still move quickly because we keep our bodies warm, which means our bodies can work quickly, can move quickly. We use food for that. But our yeast can't do that. So our yeast can only go as fast as the temperature that there is around it. So in this cold water, it's bubbling really, really slowly. The yeast in the warm water is very happy. That has bubbled almost all the way to the top. So in this warm water, it's able to eat the sugar quickly, it's able to bubble quickly, and it's able to grow quickly. So that is perfect for our yeast. So it's made the most of it and bubbled up loads and loads. So from that, if warmer is better, surely hot water is even better. But apparently not. The hot water has done even less than the cold water. No bubbles on there at all. It's just kind of turned to a sludge. So what's happened here is my water was too hot. It has killed the poor old yeast, just like the salt did. Just like boiling hot water can burn us, it hurts our bodies. It does the same to the yeast. It burns and it hurts the bodies of the yeast, so it can't stay alive and it can't grow. Depending on, if you do this experiment, depending on how hot your water is, you might find that it gets killed completely like this, or it might bubble a tiny bit because again, most of the yeast has been killed, but there's still a little bit of yeast there that's still alive and is still able to bubble. So that is our results. If you try this experiment at home, let me know what your results are. They might have been different to mine. I'd love to know if they were, or if they were the same, if they supported my results, that would be great too. You could draw or record your results, either drawing what each pot looks like, showing the differences, or you could write down what you notice and say why you think each one has bubbled the most. Bye-bye.